Okay, well, my name is Stephen Hall. I'm a professor at the University of Leicester, and my real specialization is econometrics. So I'm responsible for the background to the grade model. So what is the grade model? Government revenue and development estimations. The grade tool at St Andrews is what we think of as a visualization. That's something which is relatively easy to use. It can be used by almost anybody who's familiar with computers. And what it shows is how a change in government revenue per capita affects a whole range of the SDGs that we are normally very concerned about. It covers virtually every country in the world. It's an easy to use interactive tool, which is freely available at no cost to any of you. And I should say that we're happy to help users who are not too familiar with this tool to get into it and to come to understand exactly how to use it. Underlying the grade visualization, however, is a fairly sophisticated nonlinear econometric model. It's a panel data model, so it models every country in the world individually. It's based on data which starts in the 1990s up to the most recent data available. As I said, it's for almost every country in the world. And what it's essentially doing is to link government revenue and governance indicators to the SDGs. So if you allocate some money from, say, a profit shifted developed country into a developing country, it'll tell you how we think the various SDGs we cover will actually improve because of this reallocation of resources. The key thing behind the grade is this nonlinearity, and that's really fundamental in understanding why the grade is so effective in this area. This is what we call an S-shaped curve. It's actually a logistic curve in mathematical terms, and it's dominant in all sorts of areas of science. You can think of it in terms of how populations grow, how biological events occur, and in many other areas. And what it's actually saying is that for a long time, when things develop, you're at a very low level of coverage, and very little happens, even if you put some more resources into things, because there's so little development going on. But then, as you start to hit a growth phase, as development starts to really pick up, you get a period where there's very rapid returns to increased resources, government revenue, say, going into a developing country. And then you reach a plateau point, which is where most of the Western European countries are, where it's simply impossible to improve things further. So you might have, say, 100% coverage of electricity in a country, and putting more resources in simply cannot improve the coverage which goes on there. Now, this basic curve underlies all the different sectors of the grade model. This is just some actual data, so you can see it really does it work like this. This is looking at the relationship between clean fuels and government revenue. You can see clearly there's a lower bound of zero where countries don't use any clean fuels at all. As development increases and as government revenue increases, you reach a fairly rapid rising period. And then when you're at 100% of clean fuel use, you reach a plateau at the top. Now, most panel data models use linear equations to mimic this type of thing. And the big problem with that would be that obviously with higher government revenues, you could go above 100%. And with very low government revenues, you could easily fall below 0% in a linear context. But in the grade, we have this very strong nonlinearity behind almost all the relationships we look at, which captures what you can see, this real world piece of data. Technically, what we use is a logistic function, which you can see in the first equation there. If you like equations, that's a very standard logistic function, which simply shows this S-shaped curve going from a minimum value to a maximum value in a fairly smooth way. When you think of the picture of data I just showed you, however, you can see that the S-shaped curve is by no means unique to all countries, and it varies between countries quite a lot. So what we've done in the grade model is quite innovative. What we've added to the S-shaped curve is a set of extra variables, which are in the lower equation there. And those are the little W's inside the brackets. And what we use for this is a set of quality of governance indicators, so that we're saying that the actual quality of governance in a country can fundamentally affect the S-shaped curve. It can bring about the rapid period of development much quicker, or it can make the whole thing much flatter so that it takes a lot more resources to develop. The current coverage of the model includes a bunch of standard SDGs, the basic water, safe water, basic sanitation, safe sanitation, under 5 survival rate, maternal survival, a whole bunch of educational variables looking at primary school teacher ratios, etc. The use of clean fuels and the use of electricity and stunting in the population, as well as the 6 governance indicators, which are a fundamental part of the model. These are also endogenous inside the model, so we can show how increasing resources may actually improve the quality of governance, as well as at the same time directly improving the SDGs, which brings about a sort of virtuous circle. So that increasing governance improves the SDGs. At the same time, you get a natural increase in the SDGs from increased resources. Why does all this matter for advocacy? Well, this little table here is trying to make that clear. Before the outbreak of COVID, profits were being shifted from Nigeria to the Netherlands and running at around 689 million per year in 2019. And what we're asking here, those profits were being shifted essentially because the international financial system allows uh, companies to move their profits to wherever is most effective for them. And the Netherlands charges a relatively low rate of corporation tax on profits shifted into the Netherlands. And so the question is, what would happen if that 689 million was actually given back to Nigeria and they were allowed to tax it themselves? The actual financial flows, of course, are exactly equal to each other. So if you are arguing as an advocate that you think money should go back to Nigeria because it's a poor country and needs that money for development, and you put that point to somebody in the Netherlands, they'd say, well, this is going to cost us roughly $689 million. Why should we do that? And while I think we all see the moral imperative to do that, the actual benefit in terms of just financial flows is not so obvious there. If we had a linear model, and we haven't actually created a linear model, but looking as a simple approximation, because a linear relationship is symmetric, when we start to look at the SDGs, it would be a similar cost to the Netherlands as the benefit to Nigeria. So we calculate roughly that if you move that amount of money into Nigeria from the Netherlands, it would avert the deaths of about 651 under 5 children per year. And if the model was linear, you'd find that that would probably cause a similar amount of deaths actually to occur in the Netherlands because linear models are essentially symmetric. But what the grade model says is that moving that money from the Netherlands to Nigeria would avert 651 under 5 deaths every year in Nigeria, but the cost would be virtually zero to the Netherlands. There would be 0 deaths because the Netherlands, in terms of healthcare and child mortality, are at almost a perfect level, about as good as you can get. And so reducing their income by what's in national terms a relatively small amount would have 0 effect. And that's the great advantage we feel of advocacy in this situation. We also argue that this is a realistic model, and this is an important thing to understand about the grade system. In many advocacy cases, people argue that we should spend a certain amount of money on a certain activity. For instance, vaccinating children in a particular developing country, and they work out the cost of that. The problem with that is if you gave a developing country that amount of money, they simply wouldn't spend all that money on vaccinating children. They'd spread it around their budget, their general budget. And so that's an unrealistic assumption. Inside the grade, the assumption that we make is that when you give extra money in any form to a developing country, it's going to spend that money in the same proportions as it has historically. So we're not looking at one SDG improving as you get an increased amount of money coming into a country. We're looking at all the activities in that country improving. So all the SDGs we cover would improve, but also other things such as infrastructure building. And even if the country's spending a lot on military activity, that would increase too. So that's what we mean by a realistic model, one which doesn't make unrealistic assumptions about how a government will behave. And that is essentially my background to the grade model in terms of econometrics. So thank you for listening to me.